6. So these are the trig identities which are given for C3, and unfortunately none of them are relevant to this question. Well, the two that we need to use, both of which need to be learnt, are these two double angle formulas. So we're going to come back to this, but I'm afraid just starting off you need to have learnt these. So let's have a look at the question. So first thing first, let's go and make it a single term. We've got a common denominator, so we can just have sine 2 theta on the denominator, 1 minus cos 2 theta as the numerator. Now 1 minus cos 2 theta becomes this 2 sin squared theta as demonstrated in working 1. That's what I've done over here. So how did this work? So we've taken our double angle formula cos 2a equals cos squared a minus sine squared a. We've done 1 minus it, so in order to tie it in with what we've got. So 1 minus cos 2a obviously equals 1 minus the right hand side, and then so the right hand side becomes this. Now 1 minus cos squared a is sin squared a from our C2 trig identity knowledge that cos squared theta plus sine squared theta equals 1. So that becomes this. So we've got sine squared a plus sine squared a, so 2 lots of sine squared a. That's what we've got as the numerator. Now for the denominator, what's become of the sine 2 theta? Well, this is the working 2 over here. This is straight off what we need to learn, that sine 2a equals 2 lots of sin a cos a. So sine 2 theta equals 2 lots of sin theta cos theta. We can cancel out one of the sin thetas. We can cancel out the 2's. That leaves us with sin theta over cos theta, which equals tan theta. Now for b past b, it's hence. So always go for the hence, not the otherwise. So we've got to be using this. So we've been asked to show that tan 15 equals something. Tan 15. So let's just pop 15 into this formula here. Okay, so 1 over sine 2 lots of 15 minus cos 2 lots of 15 over sine 2 lots of 15. Obviously 2 lots of 15 is 30, so we've got this 1 over sine 30 minus cos 30 over sine 30. Now if we could just consider an equilateral triangle, each of the angles is 60, drop down a perpendicular, so we've got an angle of 30 here. This allows us to work out sin 30 being opposite over hypotenuse a half, and cos 30 being adjacent over hypotenuse root 3 over 2. So this sin 30 and cos 30 can be replaced by half and root 3 over 2 respectively. Both of these are being divided by a half. Divided by a half is the same as multiplying by 2. So we've got 2 as this first term minus 2 lots of root 3 over 2, which is root 3 as required. Now for part 2, again, focus on the fact is a hence. So we are going to be aiming to go from this to a version of this. So what do we got? So left hand side, cosec 4x minus cot 4x. Remember that cosec is just 1 over sin and cot is 1 over tan. So 1 over sin 4x minus 1 over tan 4x. 1 over tan is really 1 over sin divided by cos. In other words, cos over sin. So this term here is cos 4x over sin 4x. Now we're aiming to get it as the double angle formula. So let's just break the 4x down into 2 lots of 2x. So all I've done here is just replace the 4x's with 2 lots of 2x. So we're now in a position where we've got this completely lining up with this. So our theta is actually 2x. So tan theta tan 2x equals 1. And then we're just going to use our C2 skills where we just let capital X equals 2x. So tan capital X equals 1. Inverse tan 1 is 45 degrees. So our one big X solution is 45 degrees. We've changed our range. Little x was between 0 and 360. 0 and 360, but big X we're doubling this, so it's between 0 and 720. So using our all silver toy cars, we're looking where tan is positive, so that's at 45, 225, 405 and 585. There are 4 solutions within this 0 to 720 range. So our little x values, we just halve all of these because little x is half of big X, giving us these 4 solutions.